Thanks very much. My name is Paddy Mahon, as has just been introduced, and this presentation's title is Like HDL Modular Systems for Smarter Building Solutions. So what we're going to cover today, we'll do a brief introduction about Framespace, we'll talk about our processes, some testing and analysis we've carried out on our system certification, some collaborations, embodied carbon studies we've done, and we'll run through some case study projects as well. So about Framespace, we were started up in 2016. We're based in Longford Town, and we specialise in design and manufacture of light-gauge steel building systems for the residential and commercial sectors in 2D and 3D solutions. So what we do, we started off initially solely focused on a 2D panelised system, so category 2, a closed panel system with varying levels of finish applied in the factory. So we'll see a few pictures of that in a minute. And that expanded into 3D volumetric over time. So we do a modular solution now, and we try to get as much pre-manufactured value completed off-site with varying levels of finish externally and internally. So just a quick run through of the difference between 2D closed panel and 3D. With the 2D closed panel, you can see the picture of it there on the left, panel being lifted into position on one of our projects. So you typically be looking at a pre-manufactured value of 30 to 40%. So that's the value of works that will be completed off-site. The fit-out would be completed on-site. It's a more flexible solution in terms of it can be incorporated into a design at a later stage of a project. It has a good level of cost and program certainty when it comes to the frame facade. The fit-out is still completed on-site though. With the 3D volumetric solution, you be looking at a pre-manufactured value of plus 90%, obviously depending on the building layout and the design of it. The fit-out is completed off-site, but early engagement and considerations are important if it's going to be incorporated into a project, and the buildings need to be designed from the outset really to incorporate that into them. It has a very high level of cost and program certainty, with the civil substructure and just tying in between the modules completed on site. So looking at our processes, so our design and build workflow, we operate in a fully digital workflow and design from design to handover. So we operate in a common environment, both in design and factory and install. So we use Autodesk Construction Cloud for design, development, collaboration. We get the architectural plans in, we'll do architectural models, we'll work through the engineering, we'll develop the steel models, the M&E models, so everything is coordinated fully. From that, the information is, the fabrication information is extracted from the models automatically in some cases and just checked, and then that gets fed to the factory floor through our workflow platform, which is our factory production control platform, and that follows onto site and is followed up on site through ACC inspections. So just to talk about our factory production control, we use a workflow system, so it's a digitized platform for planning projects. All our QA checks are built into the platform as well. So at each station, guys check into a panel, they carry out their quality control checks specific to the activities that they're working on, and then they sign off. So it automatically generates a passport for each panel or each module, whatever we're actually working on. And the checks are tailored to the project specification that we'll be working on as well. It also tracks consumption and gives us full traceability on the materials used for each panel, each module. So say with a panel, we'd have full traceability of what steel coil was used for that particular panel, where it came from, what date it arrived into our factory, who rolled it all the way through to final sign-off, what lorry it got put on, and that follows through to the site team. We also do all our project scheduling on that, so the project is scheduled out on the platform, and then the floor operatives know what panel they're working on next. So it's all systemized in a way that they're built in the order that they would need to be installed as well. So that all works through. So our QA/QC systems are, as I said, are built into both Workflow and ACC. The factory control checks are carried out in Workflow for the factory, and as I said, the quality passport is produced for each panel. Again, we have 100% traceability for every profile manufactured in our plant, and then the site and install checks are carried out on ACC build, which can be done on tablets on site with photos taken and the quality checks built into it. I suppose the other important point to make is at the project outset, there's a project-specific inspection and test plan developed, and that's developed in conjunction with the design teams that we're working with, who will be, carrying out ancillary certification, the assigned certifier. So we'll go through what checks we're carrying out, the different hold points, witness points that different team members want to be part of as well. So the installation process, panels are delivered on stillages, arranged to match the installation sequence, so you're not double handling panels. They get delivered on a trailer and they're lifted directly from the trailer into position. So we're not storing materials on site, or for the most part we aren't anyway. Wherever we would be, we'd have covers to cover the panel, or you can see the picture on the bottom left there of a module being delivered with a cover being lifted off. So that is all considered as well. So yeah, and then we use, majority of our workforce are direct labour. From an installation perspective, we do use some closely related third-party subcontractors as well, but all our sites are managed by our own project managers and site managers. So talking a bit about some of the testing and analysis that we carry out for our projects and for our system. So structure part A, which should be standard for all projects. All elements of the project are designed to project-specific conditions, such as location, building height, and elevation. They're designed and certified by a competent, qualified structural engineer. So they'd basically carry out a calculation package, they'd structurally model building, and all of that would be part of the handover pack as well. From that, we model all the steel in, both the LGS and any hot rolled steel elements. So that's done in-house by our own team, and is reviewed and signed off prior to manufacture by the structural engineer that had called up the different profile sizes and member sizes. So we would use Vertex for the LGS detailing, and we would use Tekla for the hot rolled steel detailing. Fire part B. So we have a full suite of loaded fire tests on our system for external wall, compartment floor, and low-bearing wall and low-bearing internal walls. So that would cover the 30, 60, and 90-minute fire-resisting requirements. We don't rely on third-party assessment of our system. So in terms of how we would develop what fire, the test panels or the tests we would carry out, we would design them in such a way that it would be the most onerous test for that particular type of panel, so that we could use the field of direct application to upgrade the steel or quantum of steel that would be in it, or the boarding arrangement on the outside, or in terms of services that might be fitted in a wall. CWCT testing. So we carried out a full-scale CWCT test in the UK on an external wall build-up. So this is a very onerous test. It involved air permeability testing. So what you can see in that video there is the facade itself, but behind that is an airtight chamber. So during the test, they depressurize that chamber, which is trying to draw in any water or air from the outside through the facade. Then they start to apply water to the facade, and then they apply wind directly at the facade with the water. So it's driving the rain, or it's mimicking driving rain at the facade. There's 2 windows built into the facade also, so they're the key junctions that we needed to test. Window frame, the reveals, sills. And then finally there's a very onerous wind resistance test carried out, and that's done by applying pressure within the chamber. At the end of all of that, there's a hard and soft body impact testing carried out on the facade. So that's to see how it performs after all of the applied forces. So at any one stage, if water enters the chamber, it's a fail, and you start the test from the very beginning again. So it's a very onerous test and a quite difficult one to pass. Hygrothermal testing. So we've had a panel tested in a hygrothermal chamber, which exposes the panel to repeat heat rain cycles followed by repeat heat cold cycles at controlled humidity conditions. So this is designed to simulate naturally occurring conditions over time. Post the weathering cycles, there's bond and impact tests carried out on the finishes on the wall to see how it performs in terms of adherence of the materials. So we ran through our panel twice, basically, to mimic 2 full-scale cycles of the hygrothermal testing, and it performed without any issue, which is really positive. Acoustic Part E, which will be carried out on all projects as well, all party walls or separating floors. So at the outset of developing the system, we would have done a suite of acoustic lab tests, and that would have been to try and sort of see what sort of build-ups would work from a compliance perspective, and look at that in conjunction with our fire testing as well to try and get the optimum solution. So again, all acoustic testing is carried out in line with Part E requirements for projects, and we have a significant amount of site test data at this stage. Fabric and testing, or fabric performance, so Part L. So we have a full suite of thermal models complete on 2D and 3D junctions, so that'll be for our standard junctions. We end up doing bespoke modelling then for project-specific junctions as well, wherever it would be required. And then in terms of hygrothermal analysis, we'd have that carried out in our floor wall and roof build-ups for the different projects as well, just to show there would be no issue in terms of condensation. On our jobs, we typically achieve somewhere between 2 and 3 meters cubed per hour per meter squared in terms of air tightness. So in terms of certification, what we hold, we have CE EN to 90. We have our NSCI Agreement cert to construct buildings up to 20 meters to the top floor, and that's for the LGS frame system. So we're just working through the final stages of an update to that as well, to include an external wall build-up. We have UL certification for our external wall build-up, and then we have our ISO 9001 also. So just a bit of a case study. We'd worked with the NSCI around MMC ancillary certification process on a project. So we were awarded the first ancillary certification on a project in Harold's Cross in Dublin. The offering was developed by the NSI to help support and deliver the government's Housing for All initiative with the use of MMC, supporting project design teams and assigned certifiers with the inspection and certification of MMC systems that hold an agreement cert. So we were in the process of updating our cert, and just to help bridge that and give comfort to the assigned certifier on the project and the design team. This process was taken up, and it worked really well. The process involved rigorous NSAI assessment, including a desktop study of the manufacturing construction drawings, inspection of ongoing off-site manufacturing and installation of the LGS and facade process, assessment of site preparation prior to assembly, and inspection of the LGS internal and external finishes. So all in all, on that project, I think we had about 15 different inspections from the NSCI assessor, so it was very robust, really good process, and we worked really well with the NSCI. So I know Martin has said there hasn't been that big of an uptake on it, but it is, I think it is something that, hopefully others will look at, and it's a good way of, bringing everyone on the MMC journey as well, just give comfort around that. So collaborations, we're a Construct Innovate associate member. We were awarded 2 Construct Innovate Seed Fund projects in 2024. So we're working with the University of Galway on 2 studies. One is around reducing embodied carbon in the manufacture of LGS modular solutions or construction. So we're looking at alternative materials, just where we sit in the landscape, and what ways we can look to reduce that, even in terms of the size and forms of buildings. The second study we're doing is optimizing slot and stud panel connectors for light gauge steel. So we're just looking at a more innovative way of completing the vertical connections between panels to try and give a more robust and accurate connection, and also speed up the process. So both of those studies are currently underway. So I'll just talk a bit about an embodied carbon study we completed on some 3D modular houses. So we carried out an LCA after the building was constructed. So reduced embodied carbon wasn't specified at the outset. It was more commercially based. So when we did this for the entire life cycle assessment, we performed quite well in terms of factory production, and site elements were lower than traditional forms of construction. But when we looked at stages A1 to A3, which is to do with the materials in the actual build-up, there was 69% of the embodied carbon in the actual building was because of the material. So that was somewhere we obviously identified to see if there was a way we could look to reduce that. So we did the comparison between the modular building, which is highlighted there in that column, and against the same building type for traditional forms of construction. So there was a blockwork cavity wall and then a timber frame with a blockwork outer leaf. So you can see the timber frame there comes in far lower than the other forms of construction, and the modular was quite high. And that can be put down to a number of different factors, but you do have a doubling of walls in some situations and things like that. So so we went about looking at different materials that we could use to try and reduce the embodied carbon. And the first place we looked was obviously the steel. So there was a very significant reduction in the embodied carbon just by going with a greener steel, a more sustainably produced steel from Germany, but there are a number of them on the market. So that's steel produced with electric arc furnaces and with sustainable renewable systems on site to offset against the production energy. So just with that alone, that brought us right down to 420, nearly on par with the timber frame solution. We also looked at 2 other optimizations. So one was around the removal of a concrete slab underneath the modules, because there was already a floor in the modules, and we could look at removing one of the boards from inside, but that would require further fire testing. So we also included that. When all the optimizations were in place, it brought it right down to 386, which is a huge reduction from where it had been at 535. Now, below the line, below the 0 line, you can see there, that's sequestered carbon. So in that situation, in green, you can see the timber frame is still at 290. So it still performs better when you consider sequestered carbon. But with the optimizations, the LGS performed really well, and it just got us thinking about how to approach our offerings going forward. So now we do give the option of the greener steel, and hopefully in the future, I think more people are going to move to that as well. Just one other point on that is that, for the massive reduction in embodied carbon with steel, the cost comparison with that is, the proportion is quite low. So you could be looking at, €200 extra per tonne, which is not that significant really in the overall. But, you wouldn't really know until you start looking at the numbers and crunching them, just to see how it does break down. So case study projects, we'll have a look at the URMH modular homes, the KCR apartments, Riverside Manor in Kilcullen, Kildare, Drumhearney Hideaway, and a project we're working on at the minute is the MMC demonstration park in Mount Lucas. So the URMH modular homes, this is a large project rolled out for the Ukrainian refugees that were coming into Ireland. We worked with CISC and the OPW on this, and we delivered, I think it was 162 units overall. So you can see images of the single-story units there, finished out with the landscaping. The pre-manufactured value of these particular units was around 93%, I think we worked it out to be, with just cappings and flashings applied on site. It was really collaborative approach with the design team because it was very innovative. So we worked with fire consultants, architects on the project, just to work through the route to compliance with all of this as well. And look, we also worked with other manufacturers, so it was quite an unusual project in that way that we collaborated with other manufacturers to produce the exact same modules with the same performance. There are some images of the centre pictures modules being lifted into position. Again, you can see in the top left is some of the finishes inside, so most of the finishes would have been fitted in the factory with the loose furniture and light fittings and curtains and stuff fitted on site. As part of that project, we also did a pilot scheme for 6 two-story houses. So each house was a 3-bedroom house, and it consisted of 4 different modules. So there was that interconnectivity piece. There was a lot of coordination required in terms of M&E, in terms of fire compliance, and just working through all the eventualities in that. So it was a really successful project, and once you walk around the house, there is no evidence that it is a modular house, which is, I suppose that's what we're always trying to work towards. But it's worked out really well, and hopefully we'll see more schemes like that. The KCR apartments project, so that was 15 apartments in South Dublin. It was a 2D project, so you can see there what a 2D project looks like during the install. All the external walls had the external insulation system on the outside with windows fitted. The party walls came boarded, so they already had the fire and acoustic rating. So that's we'd land all the floors on top of that and get another lift of walls all the way up to roof level, get the building sealed, and that allows the M&E fit out and other fit out to be completed. There are just some other images of the project. You can see the top right of the ground floor panel being lifted in, and the bottom right is the finished product. The Riverside Manor and Riverside Green project in Kilcullen and Kildare. So we're currently working on this project. It's 110 units, mix of houses and duplex apartments. We had finished phase 2, I think it was the year before last, which consisted of 70 houses and duplexes as well. So we're working through this, which again, it's going quite well. You can see some of the other images from the project. The top right is a volumetric roof section that we complete off site as well. So that just allows us to get the building up and weathered as quickly as possible at a very fast pace, really. So I think we'd be looking at installing a typical row of terrace, 6 terrace houses, in 6 to 7 days, which is a great pace and allows the fit out to start pretty much straight away on site. Drumhearney Holiday Village, so this is in Leitrim Village. it's quite a unique project and had a unique set of requirements. So the client wanted to build a number of chalets in the woods in Leitrim Village, but he didn't want to introduce any concrete into the environment. So we had to come up with a solution that would work there in terms of how to foundations and avoiding the need for scaffold as well, because we wanted to avoid having to cut down or remove too many shrubs or trees local to the units themselves. So we came up with a screw pile solution there with their floor panels landed onto them, and worked our way up. It was quite unique, and there was quite a few challenges in terms of performance of the building that we had to work through, but it all got worked through, and the finished product there is you can see the top left is one of the triangular buildings, which is very unique. In the bottom right is a row of them in the far set, and so it's a very unique project, but it's one we're very proud of as well. The Mount Lucas MMC demonstration park, so I think this is touched on in a couple of slides already today. So it's one where we're working on two particular units there. One is the 3-bed house and one is the 1-bed house. So I think we're getting closer to kicking off on the project anyway. The design is very much developed on it, and hopefully we'll get going later in the summer on that particular project. So that's all the slides I have. I'd just like to thank everyone thank Ronan and Ray for having me, and I'm sure I'll take any questions later on. Thank you.